education superhighway. They're in San Francisco, but the school broadband situation in the U.S. not. Not at work. I like to contribute to. Before we begin, I have a quick warning. I'm going to try and be funny. I'm not always funny. So I thought, how am I going to get funny so that I can be funny for this talk? So I thought of this really famous quote by Kent Beck. So first, make the change easy. Warning, this may be hard. Then make the easy change. So I thought, what could I do to make me funny? Out of this. First, come here to Madison or Justin Searles. This may be impossible. And write the presentation. So I thought, what do they have? Emojis. They use a lot of emojis. I just wrote a heat visualizer that uses emojis. So here's some emojis. There we go. And some slightly more topical emojis. And I thought it's not just emojis. I also really like Japanese stuff. This gotta be it, right? This gotta be like the funniest slide of the talk. So, this is better? All right. So this has got to be it. This has got to be like the funniest slide of the talk, right? But no, really, I like Japanese things. I love Ruby. Ruby's Japanese. One of my favorite bands is Japanese. If you've never heard of Baby Metal, they're pretty much a speed metal band fronted by 3 teenage Japanese girls, and it's way better than you could ever ask for. But really, though, like my wife's half Japanese. I like a lot of Japanese stuff. But I have something Japanese that they don't have. I have a Shiba Inu, the national dog of Japan. That's Minky when she was just a couple weeks old when we first got her, and this is more of what she looks like today. When I come home, when I've been gone for a while, she puts her ears back and like wiggles her whole butt. It's really cute. So that's how we're going to try and be funny today, our emojis and Shibas. Quick non sequitur. I was just at RubyConf a couple weeks ago, and if you're ever at a talk with Aaron Patterson or at a conference, he will try and airdrop you pictures of his cats, which is really great. So I thought that was a great idea, and I responded with this. So, you know, if your airdrop is on, maybe expect a picture or two of Shibas, and maybe you've already gotten 1 or 2. But on to the real stuff. So, we Ruby programmers, everyone in this room, we have a problem. We may not know we have a problem yet. You might not be feeling the pain from it yet, but it's there, and it's something we're going to have to deal with. And it's Moore's Law. So, if you're unfamiliar with Moore's Law basically meant that it was theorized back in the 60s that the processing speed, well, technically, not technically, but for us, the processing speed of processors is going to double every 12 to 18 months, depending on who you ask. And that was true for like the longest time. But then it wasn't. And our users expected this. They expected applications that were twice as complex every year, but were still just as fast as before. Can you imagine how hard it would be to write a video game that we expect today 10 years ago? Like, the hardware just wasn't there. The processing power just wasn't there. We needed to rely on the processing speed to increase so that we could give our users what they wanted, which was more and more complex things that are just as fast. But I have bad news. Moore's Law is dead. Kinda. It's dead to Ruby because the way that they're building processors now, it's not just faster and faster clock speeds. It's more and more cores in a processor. So it's dead to Ruby because we don't right now have a really great concurrency story. And by Ruby, I mean MRI, because JRuby and Rubinius both can leverage native threads really well. But most people aren't using JRuby or Rubinius in production. We're really on CRuby, on MRI. And just some sort of proof and some backup to that. This is a graph of the processing clock speed for Intel chips from 1975 to 2012. And you'll see in 2004, we had a wall. Like, we were really clicking, going along, and then we stopped. It didn't even slow down. It just ended. This is mostly because we reached sort of a limit of our engineering capabilities. A lot of features on chips now are smaller than most viruses. which is crazy to think about. But when you start having electrons moving that fast and features that small, you start dealing with non-deterministic behavior, which is not what you want out of your CPU. And you start dealing with the heat that's generated by that. And it just becomes so hard to deal with that heat that they said, you know what, let's just stop here and let's start doing multi-core processing. So now, for the last, since 2004, the last 12 years now, we've been living in a multi-core world. And people have been looking for ways to take advantage of all of those cores. And a lot of people are moving to functional programming. I don't think that this is because functional programming in and of itself is better for that kind of architecture, or those kinds of restraints. But there are features that are in many functional programming languages that make multi-threaded, multi-core programming, concurrent programming, much, much easier. A lot of those features, like immutable data structures, many functional programming languages are immutable by default. They have lazy or delayed evaluation, which is just a general performance benefit in general. But languages like Haskell, where everything is delayed until the last possible moment, have made that a really desirable aspect of a language to have. There are pure functions. This isn't necessarily a language feature as it is an implementation feature, but a lot of these functional programming languages make it easy to write pure functions. They make it difficult to mutate or to have I/O, so it pushes you in a good path, very different from what Ruby does today. They have higher order functions, which, if you're unfamiliar with that, it's basically a function that either takes a function as an argument or returns a function. And they also have curried functions, which is another functional programming thing that basically says if you have a function that takes 3 arguments, you can call that function with 1 argument, and it will return you a function that is ready to take the next 2 arguments. So you can compose up functions pretty well by currying them. But I have some good news. All of these things, I'm sure you've been thinking this all along, all of these things are not just in functional programming languages. Ruby has every single one of those things today, right now. It may be a little hard, but they're all in Ruby. So we have immutable data structures if you really want them. We have the freeze method. It doesn't always do what you expect, but we have it, We have lazy or delayed evaluation. We have the lazy method on enumerator, and there are lots of other ways that you can design your programs to be more lazy or delayed in evaluation. One of the best instances of this, I think, in the last couple of years was active record being lazily evaluated. I mean, that's such a great example of lazy evaluation and the benefits that you can get from that. Pure functions, again, that's more of a implementation detail than a language feature. It isn't as easy to do in Ruby because mutation is so natural and so part of Ruby, but we're going to go over that in a little bit more detail later. Higher order functions, this is one thing where I think Ruby kills it because we have blocks, and blocks are one of the best APIs, I think, for higher order functions that you're ever going to find. The block is such a great, elegant API for a higher order function. You don't even know that you're using this really fancy schmancy computer science term when you write an each loop, but that's what you're doing. And we have curried functions. This is something I actually learned kind of recently. There's a curry method on proc in the standard lib. So that's there today. You don't even have to write it. We're set up to do this. We just aren't. And so I think Ruby could still be a language of the future, but we need to change how we write our programs. We can't keep going with what we have today because it's just not going to work with the architecture. Users are still going to want faster and faster programs. They're going to want that performance. But unless we can use all the cores on our machine, then we're not going to be able to give it to them. That's just the way the architecture is pushing us. And I know there's a lot going on right now. There's a lot of talk about Ruby 3, and Koichi has his guilds proposal, which is going to be a way for us to start doing better concurrency and using threads more and being able to do more of that concurrent programming. But I think we need to think more about it today because it's important. And we need to start experimenting because we shouldn't just let 1 or 2 people decide what the future is going to look like for Ruby. One of the best things about Ruby is the community. And we can all work together to experiment and play and come up with new things that might work for these sorts of situations. And we can probably design a really, really good next version of Ruby if we're all working together on it. So today, what we're going to do is we're going to refactor some code. We're going to go through some stuff that's totally normal Ruby, and we're going to refactor it, but with a little bit of thinking about the future in mind. We're going to try and think about how this will work for the next 5 or 10 years. If we were to never touch this code again, could we theoretically make this really easily multi-threaded? So I love football. We're going to today play around with a fictitious little API wrapper. So let's imagine that the NFL has an API that you can hit. You can get some data back from it about a game or about a team. So you can either ask it for data for a team or data for a game. You give it different stuff depending on what you want. And we're writing a little CLI and a little API wrapper for it. So here's what the little CLI script looks like. No surprises there. Totally normal. And then here is what our client looks like. So we give it an API key, and then we have those 2 public methods that fetch for team and then fetch for game, data for a game. And basically what we do, we build up URL, we fetch the raw data, and then there are some other private methods that basically just add some metadata on to what's returned from the API. And here's what a little bit of those private methods look like, and also what our fetch raw data method looks like. So we just get a hash, and we inspect what's in that hash and add some more data to it. So we're adding more metadata. But this isn't great. You know, I think we're all probably itching a little bit looking at this. This is very clearly a smell. We have 2 things that are totally different here living in the same class. So the normal Ruby thing to do would be to reach for extract class and pull out some of these things that are kind of the same. You know, we've used some colors here. The green stuff, we're building up that API, the URL. The blue, we're fetching the data, and then in the purple, we're going through and adding the metadata. So yeah, let's extract some classes. So our new CLI will look like this. We have a class for the team, a class for the game data, and we have 2 clients now. And we can call them just pretty much the same as we did before. And of course, there's going to be some shared data, so we should extract that into a base class that they will inherit from. They fetch raw data in the same way. They both take an API key. So we can extract that. And then here's what our classes look like. We can inherit from our base class and then build up the URL, basically do the same thing. And I've sort of folded up all those private methods because they're not going to change. They're not super important, but we know what they do. They modify a hash. And then here's what the other one looks like. Pretty much the same, right? So not bad. You know, I've seen worse code in my days. But I do have some problems with this. First off, we have inheritance. I try and avoid inheritance if at all possible. Inheritance, frequently you see it where it doesn't quite work. You know, these are 2 Shibas, but they're really different Shibas. And as they grow up, they will become more and more different. So that usually happens. You start with what you think is a really great abstraction, and you create an inheritance hierarchy, and then you start adding all kinds of conditionals and, like, you know, if super, else this. So I try and avoid inheritance if I can. The other thing I don't like about the code that we had was the mystery guest anti-pattern. If you're unfamiliar with the mystery guest, those 2 things in purple could either be local variables, they could be method calls, but nowhere in this class are they defined. They're coming from somewhere else. Now, I know you're saying, Devon, how lazy can you be? You just open up the other file, you see the implementation if you need to see the implementation, and clearly they're coming from the base class. But if you've ever tried to read through some of the deeper parts of the Rails code base, you know that this quickly gets out of hand. And if you have an application of sufficient size, and you're using inheritance and module inclusion, which is inheritance, anywhere in your code base, or all over your code base, you're going to have a lot of this. You're going to be looking at yourself saying, oh my God, I have no clue where this is, and it's in one of these 60 files. So I try and avoid this if I can, and we can avoid this. So, but there's one bigger problem. The biggest problem is testing this. So if we want to test this class, and we want to test that single public method, we're going to have to stub out the object under test unless we want to hit our API every time. We're going to have to stub out that fetch raw data method. And that's a no-no. No stubbing the object under test. So let's fix that first. That's the easiest thing. We can extract that as a collaborator. So we'll edit our base class to take a fetcher. And that's going to be the thing that actually fetches the data from the API for us. And then we will update our one of our classes to call that fetcher. Now, the fetcher itself, in this case, is still a mystery guest. We don't know where it comes from, but we have a little bit more information about what it is. We know that it's a function. How do we know that it's a function? Well, it responds to call. So in Ruby, there are lots of things that respond to call. You can call a lambda, which is a function. You can call a proc, which is a function. You know, those two are pretty much the same thing. You can call a method object, and you can call a block. These things are all functions in Ruby world. So if you're writing functions, you can very easily convey to the reader of that code that something is a function by responding to call, especially if that's the only public method on that object. That's not always the case, but it's a good thing if you're designing APIs. That's a good thing that you can look for. You can also call a Shiba, but it doesn't always do what you want. They're really great dogs, but they're so stubborn. But anyway, let's use a lambda. Lambdas are nice. I like lambdas. I use lambdas a lot. So we can define a lambda that does the actual calling of the API for us. We can give it a URL. It'll fetch all the data for us and return it to us in a hash. And then we'll have to pass that in to all of our client classes. Now that solves that problem. You know, we can test that more easily now. We can pass in a test double or a mock object, whichever nomenclature you prefer. But now the user of our CLI has a lot to do. I don't really like this. I think we might have gone down the wrong path. So let's go back. This was nice. I liked this. Let's stick with this. And then we'll go back to here. So we know we have duplication. We know we need to extract something. I still think extract class is a good refactoring to reach for, but I think we can use some method objects here. So the method object is a design pattern that I first heard about in Martin Fowler's refactoring book, which basically says if you have a really big method and there's a whole lot going on in it, you can pull that out into its own object. You can extract that functionality into a standalone object that does that one thing, which is great. That's what we want. We want single responsibility objects, single responsibility methods. And I like method objects basically as functions. As we can see here, we can extract all of those private methods, put them in the class that they belong to. We can extract the other functionality in those public methods and put them into a single class. And we can spin a class up, and we can encapsulate all that behavior within a class. And those classes are functions. They respond to call. They have a single private or a single public method. I love this. I use the method object everywhere because there are a lot of benefits of them. But first, let's take a look at those classes. Now, in here, that's pretty nice. You know, single public API, really easy to test, really easy to pass in, you know, a fake fetcher in our tests. I think it's really understandable. It's easy to see what's going on. This is good code to me. And then the other one is kind of the same, though. We still have a lot of duplication going on here. I think we can do slightly better, though. I think we can change these to be pure functions. So if you haven't heard the term pure function before, pure function needs to meet two rules to be a pure function. The first is that it has the same output for a given input every time, no matter what. Okay? Second is the hard one. The second is no side effects. That means no I/O, no touching a database, no touching a file system, no printing to a console, nothing. Now that second one's really restrictive. Like, you can't have a program that just calculates the first 1,000 Fibonacci numbers and quits, and like doesn't even put anything to a program. That serves no benefit. You need side effects for a program to do anything. But you can still do a lot with mostly pure functions. And there are a ton of benefits to pure functions. First and foremost, they're really easy to test. Oh, come on now. So they're really easy to test, and they're really easy to test drive. If you're TDDing a pure function, you have no setup other than what goes into the function. You don't have to create stuff in the database. You don't have to do any of that stuff. It's really, really nice to work with pure functions in a testing environment. It's super easy to make them thread safe because you know that it's not mutating anything outside its scope. It's not relying on anything in the outside world. Everything in there belongs to that function and that function only. So you can make it really thread safe really easily. And they're highly composable. A pure function is, I think, just about the most loosely coupled object you can possibly have. It has no dependencies other than what you give it. And you can change what you give it really easily. It's a lot easier to change a single instance of a pure function than it is to add a conditional in somewhere along a 10-object inheritance hierarchy to handle that one case that you need. So that loose coupling gets you a lot of benefits for composability and for flexibility. So let's play a quick game of Is It Pure? We're going to look at some of the methods in Ruby that are there today, and we will see, are they pure functions or not? So the first one, IO read. Clearly not, right? It's touching the file system. It's reading something from the file system. And that means stuff like this can happen. You know, the second time you call it, you can get an error because maybe someone renamed the file, or maybe the file's missing, or maybe it was just a temp file. Those are sort of that's the complexity you have to handle when you have functions that aren't pure functions. Integer plus will always be what we expect it to be. It doesn't touch anything in the file system. 2 plus 2 will always be 4. That's a nice pure function. You know, if you had to test that, you all know how you would do it, and it would be really nice. You'd be really happy with those tests. You know, there's very few edge cases. It's nice. String downcase. So we create a string. We downcase it, we see it returns the string downcase that we want, but has it mutated the original string? No. So that's nice. We know if we want to mutate with downcase, we need to use downcase bang, right? Everybody knows that. The bang methods are the mutatey ones. And then the shovel on string. So we create a string, then we shovel some other stuff on, and then, you know, there's no bang, so of course it's, oh, but it does mutate. So there are a lot of things in Ruby that mutate that you may not think mutate. Concat, you know, there's no bang on concat, but it still mutates the original object. It's harder to write these in Ruby than it is in other languages, and it's harder to write them in Ruby today, but I think we can do better. We can grow, and we can try and get to a better place, and it's coming too, but keep a lookout for this accidental or like, I didn't know that mutated something. It's a little hard. You have to pay attention to do it right. So we're going to go back, and we're going to write some pure functions. Our CLI code, unchanged. That's still good. I still really like that. And then our client, what we're going to do is we're basically going to push the unpure stuff, the fetching of data from the API, back out, a level out for our application. So what remains are these things that are basically adding metadata. So we pass in a hash, and we inspect that hash. We do some stuff with it. We add some metadata to it. And now we have pure functions. One of the ways that you can use pure functions but still maintain actual functionality is you try and push the side effects to the boundaries of your system. Then you still get the benefits of testability and changeability and composability of these pure functions while still having the benefit of the side effect. And I find in my code it helps me find duplication a lot easier, actually, because it's already in fewer places. So when you see smaller duplication that you maybe have to abstract slightly, you can see duplicated concepts really easily when you're pushing that stuff out into the boundaries of your application. So let's take a look at one of these API or those metadata adders. Can't get much more simple than this. The class method self.call is something that I just like to do to make it easier to test. That's like a thing I do frequently, because then if I'm passing in a test double, I don't have to pass in something that responds to new and then returns something else. I can just have it respond to call and then give it what I want it to do. So it just sort of saves one step in the testing process, but I think that's nice. So we have this, and then all those private methods, and we're returning a frozen hash, which again is kind of frozen. If you didn't know this about freezing a hash, it doesn't actually freeze the values of the hash. It just means you can't add or remove a key value pair. But if you have something that's mutable as a value, you can still like shovel another string onto the end of an array, or mutate a string that's a value or a key. So those are the kinds of things I'm talking about when I'm saying that freeze may not always do what you think it should do. But those are the things that I think we can improve upon in future versions of Ruby. And yeah, this is the second one. So again, returning the frozen data. And the frozen data is going to be important when we have thread safety concerns in the future. It's in hearing Koichi's talk at RubyConf about guilds, one of the things that's going to get really important for performance sake is freezing objects. because if something's frozen, then it can be shared across guilds really easily, whereas you don't have to duplicate it when you're sharing it to another guild. So getting used to writing, working with immutable objects and freezing your objects is going to get more and more important as time goes on. And it's good to start thinking about that now and getting used to it now. Because if you don't have frozen objects and you have multiple things working on the same piece of memory, you get weird bugs and you end up stuck, like this Shiba, who's very, very stuck, but doesn't seem too unhappy about it. Or stuck like this Shiba, who's still really happy about a very precarious situation. So, some takeaways. If you take nothing away from this other than these things, I will be okay. One, method objects are your friend. It's really easy to extract a nice like 30, 40 line of code object that does one thing and does it clearly, and it explains to the future maintainer of that code what's going on. You can use explaining variables, and you can use explaining method names. You can structure processes and objects in a way that makes it really easy to reason about that code. And also they're easy to test in isolation, and it gives you a seam for testing. You can mock other objects out if you need to, or you can pass in test doubles. Avoid the mystery guests. This is just like my personal thing. I find that I am so much happier and I work so much better when everything I need to care about is within the scope of the file on my screen right now. If I don't need to keep a whole system in my head, I can work so much better when I know where everything's coming from within the scope of a single file. It's a thing that not a lot of people find as a problem, but for me, that's a goal that I always try and work towards, is making everything transparent. There's a concept that some people I've seen described two ways, where referential transparency means that like everything you see, the reference to it. And then there's another more complicated computer science-y definition that I don't really understand. But that's what I think of, is you see the references to all of the things. You know where they come from. You don't need to dig through the code to unwind some big ball of inheritance hierarchy to find out where something was defined and how it functions. Look for pure functions if you can. They're really nice to work with. Method objects are great pure functions, but they're super, super nice to work with. Having more of them in your code base, I can almost guarantee you, will make you a happier, more productive person. I know that's a really crazy guarantee, but I can almost guarantee it because they offer so many benefits. It does mean that you need to work a little harder. It's not the default in Ruby. Mutation is sort of the default. Mutation is a lot of what we do. But you can do it, and it's worth the effort. And I think that we can do more in that field. Delay and group side effects. So if you're going to have pure functions, you need to delay and group your side effects and push them out to the boundaries of your application in order to still do the things that your application needs to do. And also start thinking about the future. This is the biggie for me. So I mentioned I was at RubyConf a couple weeks ago, and I was talking to some of the organizers, and they said that attendance was down at RubyConf US this year. And someone else had said that that might be the first time that's ever happened. And Ruby is a great language, but there's a lot of competition right now. And Ruby used to be on par on pretty much most levels with most languages. But now that we have a language that was invented in 1993 and really hasn't had a significant overhaul since then, we're in danger of stagnating. And if we stagnate, then we might decline. And if we decline, then eventually we might not be so great anymore. We might not have a room full of people here at an Italian RubyConf. The only way we're going to get better is if we have a diverse group of people thinking about how we're going to get better. And for most of us, that is time that we might not have. But for some of us, we might have that time. And it doesn't take a lot of time to think every now and then, I wonder if this would be thread safe. Or I wonder how this might work on JRuby. Or even just digging into some of the things that are in there to handle concurrency in the current Ruby standard lib. Like we have a thread safe queue library. We have mutexes. Those things are there, but most people, from my experience, don't use them. So learning a little bit more about our multi-threaded future and trying to bring that into the code we write today is going to help us continue to thrive and grow and be a great, awesome community. I've learned several languages in my time, and the community of Ruby is really unique. And I think that's maybe our greatest strength. And that's something that we can all work together to support and to continue to develop. And this community is worth saving. It's worth saving. And we need the language to have the community, which is the crazy thing. So I really encourage you all, think about the future, even just a little bit. Every little bit helps. And that diverse set of opinions and experiences is going to help us come up with a really great future. So that's what I have. Grazie mille per l'ascolto. Chi ha domande? Yes. So I don't use monads every day. It's actually something I've wanted to do. I've wanted to write a gem that hooks into the active record attributes API, now that that's available, and like turns all of your attributes into monads just in case they're nil, because I also hate nil. That's my other like pet hatred, is I hate mystery guest and I hate nil. But no, the only one that I use is adamantium for freezing. So that's the only one that I actively use. The rest of it is just more about sort of design and yeah, it's more about how I design my code than about the other gems that I use for right now. Yeah, yeah. So there are a couple of gems like that. There are ways that you can. I've used one before that spins up separate processes. I don't know if that's concurrent Ruby, but I am aware of that. I think Sidekick used to run on it before. Yeah, before Mike rewrote his own deal. Yeah, but it's still. I mean, I don't want to say show of hands, but like, who uses that gem here? It's something that very, very few people think about, and that's the purpose of this talk, is to get people to think about that. There are things that are there, but because it's not in the standard lib, because it's not the way that we think of as the Ruby way, it's something that a lot of people don't dig into all that much. And we still, even with that, I think it still has to contest with the global interpreter lock. So it's great for I/O. Like we do have native threads in Ruby, and you do get threading benefit for I/O, but we still have the GIL. So if you're doing any sort of complex computation, you're still only functionally running one thread at a time for everything but I/O. And yeah, I/O is where most of our programs are constrained, but that's today. That's not in 10 years from now, when people are expecting something that is, what, 2 or 3 orders of magnitude faster than what we have today, so, or more complex with the same amount of speed. So, yeah, I mean, that's a great thing, and I would love for more people to use it and to think about how they could use that sort of gem in their code today to get some benefits. Well, for now, you know, for right now, not a lot of us are feeling this pain. But I can't see in the future, when the standard is going to be 128 core CPUs, how we're going to spin 128 processes at 300 meg. You know, 200 is a nice Rails. Like you're not using that much. You're doing really well on active record. I've seen a lot that are like, like no lie, I've had processes that have used 2.5 gigs of memory in production. Because, you know, we let a lot of junior engineers ship a lot of code, and they're N+1 bugs. You know, it's gonna happen. You're gonna load sometimes 2.5 million active record objects into memory at the same time. It's gonna happen. But for right now, yeah, you can do Puma. You know, I use Puma in production, and we have it set for, I think, 3 processes and then 3 threads per process, because you still do get a lot of benefit for having a threaded web server, because again, a lot of that time is spent in I/O, and Ruby can handle that naturally really well. But we need to think about the next step beyond that, because there are some core parts of the language that just are not built in a way to help us do this. Right now, you need to fight Ruby to do some of this stuff, especially if you've ever seen some of the stuff in Rails that makes it thread safe. Like, it's not easy. They have to work really hard to make Rails thread safe. And it should be easier. And it's going to have to be easier, or else people are going to stop using Ruby, because that's what we have to do in the future. So most of the way that I do it is by, again, trying to touch the database as little as possible. We actually use the command query responsibility segregation pattern. So we try and push all of our writes to the database off to very specific parts of our application. And right now, we're not running on JRuby or anything, so like I feel totally comfortable. And we also, I work mostly on internal tools, so like I'm not dealing with tens of thousands of concurrent users at the same time, but I would recommend letting your database do its job. Like it's pretty good at doing what it needs to do and making sure that you don't have contention, and making sure that we have you're not touching the same data twice or things like that. So I try and just delay and group those side effects as much as possible. That's sort of the best way I've gone about it. Because even in Elixir, for example, they have not really an ORM, but they have something that talks to the database. And you still need to use that for a web application. But the way that Phoenix, which is sort of like the Rails of Elixir, is designed is it sort of it forces you to do some things that are harder to do by default in Rails and in Ruby. So yeah, the best advice that I have is unfortunately just sort of try and push it out to the boundaries of your application. Pretty much for me, anytime I touch a model, it's either in a controller or pretty much always in a controller. I try and pass a lot of stuff through, but other than that, I really don't touch stuff other than in controllers. That's the boundary of my application for me. I will do any saving or stuff that I need to do at that point. No. I would only update when it, whatever we're doing with our user, I wouldn't actually do until it's ready. Like I would push that back out to the controller as much as possible to the boundaries of the application. Like I wouldn't update that original instance. I will copy or duplicate objects, which is a little bit memory intensive. Like, are you saying like if I need to set a couple attributes and then save it? Yeah, so like I will do that updating and setting of the attributes and then return it to the controller to save at the controller level. Like I don't really use like the update method all that frequently in Active Record. I typically will do like the dot something equals and then save at one point later. Yeah, one more. Yeah, so it has. We've felt the pains of the current Ruby garbage collection process by, when you do have those n+1 bugs and you take that 1.5 gig of memory because of the way Ruby's garbage collected. It's not a compacting garbage collector. It's not actually probably going to release those pages back to the OS. But sort of as an example of what I'm hoping to get across is I think more people are doing these kinds of things now, and I think part of the reason that Aaron is working on a compacting garbage collector today is because more people have these kinds of problems. And the more that we do these things now, the more pain that we feel, the more we're going to start finding solutions for that pain. We can't just ignore the pain of the future and hope that it gets fixed. We need to feel that pain, otherwise we're not going to find solutions. But I actually think the current garbage collection is a problem, and people know that. And that's why Aaron's working on making it better. And like they're this close to a compacting garbage collector for Ruby, which is really cool. Like that's going to make a huge difference. It's something that a lot of people didn't think was possible, but it's getting there. But yeah, there's definitely pain. Being at the front of change means pain. But when you feel that pain, you can do something about it. And we need to do something about it. Cool. So I think that's it for me, guys. Thank you.